Good day, guys. Hope you're well. In this video, we will be looking at November 2023 question 10. Yes, that was probability. So that was 15 marks. So as we are preparing for November 2024. If you're new to this channel, guys, what are you waiting for? Kindly subscribe, right? You only subscribe once, right? Thank you guys, for those of you who have subscribed, for those of you who keep supporting the channel. Like, comment, and yes, we really appreciate. We are around 958 subscribers. We are left with 42 subscribers. Share the video link and let's make it happen, guys. We are on our road to 1K subscribers, in which I really appreciate you guys. Thank you. So let's get to today's video. At 10.1, we are given that A and B are independent events, such that probability of A is 1/3 and the probability of B it's 3/4. Then they said determine the probability of A and B. Well, for independent events, the probability of A and B will be the product of A multiplied by the product of B. So it's a product of A and B, actually, meaning that we are going to multiply 1/3 multiplied by 3/4. Then we get the solution. For 10.1.2, they said calculate the probability that at least one event occurs. So it's either the probability of A or the probability of B. So let's put that into practice. Well, so just as I've stated, so we are at 10.1.1, right? So we need to calculate the probability of A and B. Okay, guys, so that will be the probability of the product of A multiplied by the product of B. So from here, I am going to say probability of A and B. Remember, A is given as 1/3 multiplied by 3/4. So in this case, if we have to multiply these products, we can see that 3 and 3, they're the same, they will cancel. Then we'll be left with 1/4, right? So meaning that the probability of A and B is equals to 1/4, right? So if we were to leave this in decimal, that will be 0.25, right? So we go to 10.1.2. Remember, they said calculate the probability that at least one event occurs. So it's either the probability of A or the probability of B. So that will be the summation, actually, which is the addition rule. So it's gonna be the probability of A multiplied by the probability of B subtracted by the probability of A and B. Yes, so remember, we use this formula when there's an intersection, meaning we have an intersection, they intersected 1/4, they intersected 1/4. So you can another way of doing this is you can use a Venn diagram, right? So we are calculating it's either the probability of A or the probability of B. So in this case, we are going to say 1/3 plus 3/4 minus, let me just put it in bracket, 1/4. Then let's punch our calculator, or we can do it mentally. If we are capable of doing it mentally, that will also be great. So that the solution is 5/6. Another way will be since it's at least, the probability of at least, you can just say 1 minus the intersection. The intersection was 1/4. 1 minus 1/4. No, it doesn't work in that manner. So I'm wrong. So I prefer that. Let's use this one. Yes. So our solution is 5/6, or you can use other alternative methods, So we are on a safe mode, right? So let's go to 10.2. Well, at 10.2, they said that the probability that it will snow on the Drakensberg mountain in June is 5%. Right? When it snows on the mountain, the probability that the minimum temperature in central South Africa will drop 0 degrees is 72%. So in this case, we have a probability that it will snow. We have a probability that it will snow on the mountain. We're also given the temperature. So two things, right? Temperature and snow, right? So if it does not snow on the mountains, the probability that the minimum temperature in central South Africa will drop below 0 degrees is 35%. Okay, so represent the given information on a tree diagram clearly indicates the probabilities associated with each branch, right? So in this case, we need to convert this percentage into decimals. So when we put them on a tree diagram, firstly, in a tree diagram, we have two things. It's either it can snow or it will not snow. So let's put that into practice. Well, we are going to put that it's either it will snow or it will not snow. So in this case, the probability here, since they said that it will snow in Drakensberg mountain is 5%. So when you convert 5%, what are you getting? 0.05. So out of 100%, when we say 100 minus 5%, we get 95. So convert 95 into percentage, that will be 0.95. Right? Are we together? So in that manner, we will be safe. That's our first branch. So let's put other parts. So under snow, it's either the temperature. Now let's focus on the temperature. We have done with snow, right? Now let's focus on the temperature. They said that when it snows on the mountain, the probability that the minimum temperature in central South Africa will drop 0 degrees is 72%. So when you convert 72% when it snows, remember that will be 0.72. 0.72. So what is out of 72%, we are going to say 100% minus 72, we are getting 28. So that will be 28%. Convert to decimal, that will be 0.28 under when it snows on the Drakensberg mountain. So what happens, let's draw another branch. What happens when it does not snow? Yes, on when the temperature drops, remember here, when the temperature drops below, and when it won't drop below, here I will say when it drops below, and when it doesn't drop below. So I'm using WB, drop below and it won't drop below, drop below and won't drop below. So let's go to the second statement. It says that if it does not snow on the mountain, the probability that the minimum temperature in central South Africa will drop 0 degrees is 35%. So that 35%, remember, it says it will drop. So meaning that 35%, you convert it to decimals, that will be 0.35, right? So we just have to be careful. So that will be 0.35. So out of 100%, when we take out 35, what are we left with? We're left with 65. So definitely this will be 0.65. So please kindly draw yours neatly. So we have 0.35 when it drops below 35 degrees. It won't drop below, we are going to have 65%. So in decimals, that will be 0.5. Now we have represented our diagram on a tree diagram. So that's how you're going to get that beautiful 3 marks. That was 10.2.1. Remember, you're working on November 2023, paper 1, grade 12, mathematics, right? So what are we? We are at 10.2. Let's see what do they want. The 10.2.2. At 10.2.2, they said calculate the probability that the temperature in central South Africa will not drop. So we will focus on those that have WB won't drop, right? So let's put that into practice. So for those that they said calculate the probability that the temperature in central South Africa will not drop below 0 degrees in June 2024. Specifically, that means that we are going to focus on this one, won't drop, as well as on this one. So meaning when it snow, the probability of 0.05 won't drop below, that will be 0.28. We will also not snow, but won't drop below, that will be 0.65. So we are going to say 0.95 multiplied by 0.65. So our answer rely on our tree diagram. Once you have drawn your tree diagram in a correct manner, you'll be safe. So let me calculate this using our CasualFX or any suitable calculator. 0.05 multiplied by 0.28 plus 0.95 plus 0.65. What is that? Okay, let me punctual. So I'm having 0.05 multiplied by 0.28 plus 0.95 multiplied by 0.65. What are we having? Our solution is 0.6315. So that's the probability. That's the probability that temperature in Central Africa will not drop below 0 degrees. So that's how you would have gotten that 3 marks, right? Just follow instructions. Then we are at our last question, which is 10.3. Our last question, 10.3. 10 learners stand randomly in a line, one behind the other. Well, we are in how many different ways the 10 learners can stand in a line? Well, there are 10 ways that the learners can stand. That means it will be 10 factorial. In other words, it's 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 till 1. So our solution here, we are going to say 10 factorial. So let's put that into practice. Well, at 10.3.1, we said it's 10 factorial. So if we punch that in our calculator, what is 10 factorial? Remember, 10 factorial, it's about, that will give us 3,628,800, right? And 800, yes. So that's the solution at 10.3.1. Then we'll look at our last question, which is 10.3.2. Well, at 10.3.2, it says calculate the probability that there will be 5 learners between the two youngest in the line. They said calculate the probability that there will be 5 learners between the two youngest. There will be 5 learners between the two youngest learners in the line. Well, first, guys, in this case, you are going to choose the position for the youngest learners, right? You will choose the position for the youngest learners. So we need 5 learners between the two young learners, right? So let's say it is placed, let's consider maybe using any variable. Let's say they are placed in X manner. Then the other one will be placed in X plus 6. Why I'm saying so? To ensure that there are exactly 5 learners, guys, right? So let's put that into practice so that we come up with conclusion at our last question. Remember, as I've stated, so in this case, guys, we need 5 learners between the 2 youngest. If one youngest learner is placed at n, then let's say it's the youngest learner is placed at n, the other one might be placed at n plus 6, right? It's just my conclusion here, right? So the first youngest learner can be placed in position from maybe, okay, it can be placed from position from 1 to 4, right? It can be placed from position 1 to 4. Since they are placed in position 5 or beyond, there will not be enough space to leave for the 5 learners. Hence, in this case, guys, we'll have 4 possible options, or 4 possible pair of positions, right? We will have 4 possible options. So since we have 4 possible options, guys, remember, we are being told that calculate the probability that there will be 5 learners between the 2 youngest learners in the line. So if I remember, we have 10 factorial. So if I say 10 minus 2, I'm going to be left with 8 learners. So when I arrange these 8 learners, so in other words, I'm having 4 possible positions multiplied by 8 learners. That will be 8 factorial. So what am I getting? 4 multiplied by 8 factorial. That will be 161 to 80, right? So we are here. So another thing that I want you to, it's for us to account that there are 2. Remember that there are 2 youngest learners, and also these 2 youngest learners, they can switch positions, right? Since they switch positions, we can multiply by 2. Multiply by 2 here. This 161,280. If you multiply by 2, what are you getting? You are getting 322 as well as 560. 322, 560. Yes, we multiply by those 2 young learners. Remember, they can switch the positions. So if we were to we are to calculate the probability that there will be 5 learners, so probability that there will be 5 learners, 5L, so will be the possible outcomes. We said it's 322. Remember, it's favorable outcomes divided the number of outcomes. So it's 322, 560. Divide that by the number of possible outcomes. There were 10. So there were 10 factorial, in which we got 3,628,800. So let me punch that. Divided by that 3,628,800. What am I getting? I'm getting 4 all over 5. 4 all over 45. Sorry for that. 4 all over 45. So what is 4 all over 45 in decimals? It could be 0.88. So that's the solution here, guys. That's the solution. Yes, at 10.3 was beat a higher grade question. Well, there are those tricky questions, but they need you to analyze and use your critical reasoning so that you get them. Yeah, so that's how, guys, you can tackle probability. My advice is that study your independent events and dependent events. Study your counting principles. Then you will never go wrong, because they change this code. Sometimes they can use digits. Sometimes they use different types of coding. You need to study all the probability. Then you'll be on the safe side. If you're new to the channel, don't forget to subscribe. You only subscribe once. Thank you, guys. See you on the next video.